ELISA's cross community. Well, the next thing, example system with the ELISA's cross community effort. To fit them all, I made this font a little bit smaller with AGL, Eclipse, Asper, kernel CI, Xen, Zephyr, and more. With a Carbon, you have slides after me on the AGL, SDV, EG. They are included. So I do it very briefly so that you can take over, because I have not too much to put in. So let me just see that it works. The motivation is that you can go to fairs and see beautiful demonstrators, and then you ask, can I reproduce them? And they say, yes, here's your SD card image. No, reproduce, like build it, have everything there, understand it from scratch. And it's very complicated. This was actually when I was talking with Stefano Stabilini. I think it's he was the one maybe it's called. I'm trying to create the demos on it with Xen, Zephyr, and Linux 2022. And where we took this was in the Meta ELISA, where Jan Simon prepares the demonstrator and brought it here. We didn't do that much. We brought this danger side into the demo, which is whenever it's a corrupted communication on the canvas or showing something, then it's illustrating a danger, and since here's something that no longer consists in your workflow. It's a simple mock-up. There's not too much in there, but it's just to illustrate this. The real interesting part is that we created a pipeline flow, which is fully dependent on each other. So I mean, we test an image which is going on a QEMU part. The QEMU is built within GitLab, but it's taking the container and create the container based on the documentation of the Docker file, which is existing and based on the documentation. So when you change something in this chain, it will most likely break in the testing side. And that's what we observed over the last years. Actually, it was broken for a year because we were not so actively working on the use case anymore. And therefore, I'm super happy when we have it running again, especially now with the new approach. And what we really had in there that wherever you came up, maybe you just want to experience the Linux side. So you can go to the QEMU image, and this is accessible to everybody. Or you want to build the things, but you don't want to build from scratch. You have to put, so you have an S state, which is cached. Or you go even on the Docker file, and maybe you want to create a system on your own completely, then you can use the guides and read the plain documentation, really go step by step through everything. This was the intention of what we have created. And what we see, because we had all the people joining the automotive work group and just like, oh, I want to do this with the system, I want to do that, how do I start? And that's why we had some iterations on this. Here's the pull request which we had, and which is basically currently open for bringing it to ScoutGap and the Super Salmon branch of AGL. We were really, I think we've been on Koi, right? I think we were on Koi, whatever. On an older release 2 years back. Go back, yeah. That's where we've been. So that was short just what has been in the automotive work group pointing here, because it could be something for the SDV expert group use case, because there's instrument cluster involved. That's why I brought this up. And we have the example system within ELISA, which brings in Xen, Zephyr, different flavors of Linux. Mentions container, but we actually don't have containers in so far. It's just something which could be a topic for another. And it should showcase all the things which the other work group feed in. And the work group should have an environment to just see like, oh, the system is more than just my Linux. And this really has a cross-community effort. So we were discussing with Xen and Zephyr in detail, where we also have AGL involved as the Linux flavor in there, talking to SDV people who just disappeared. But that's where we are. And we have Yocto involved as build tooling. And it's really important to share this information because we're all going on the same path and we have great ideas. And I mean, you see by sharing in the open, like my slide said in the previous part, where I just got the offer to get update on some through and get some corrections, and that's just sharing by the open. You get this feedback from experts. And this was how the demonstrator looked like on Xilinx XU 102, super expensive board. So we would like look for new candidates and so on. Maybe we see it in the SDV expert group part. These are the elements of it. There's the demo part documentation. And now I hand over to
okay.
so here's that's the good button to press. I take your seat, boy.
Hi everyone, I'm Yuichi Kusakabe from Honda Motor. So I have a very quick introduction about myself. So I have a lot of experience automotive industry software development. And 2020, I joined Honda Motor in-house IBI software development team. And last year, Honda launched the Honda open source program office, and currently, I'm my responsibility SDV. SDV is a software-defined vehicle, a software chief architect, and also tech lead. So last year, Honda have joined the ELISA project because SDV is a very good turning point in automotive industry. Maybe SDV is a buzzword keyword. So in this means I'm open source guys, and I'm very beginner automotive functional safety, but ELISA is very helpful to our project. And another topics are Honda get a self-certification open chain, open source compliance, and open source security assurance because we have a lot of open source components in real products. So this is a very helpful to our software development in our team. So this is we have a lot of software development team in Japan, some branches. So if you can't find the open source meeting room in Japan, please contact me. So in this case, Honda will participate the open source community meeting room in Japan, many areas. Sorry. So this is 2 years ago, Honda launched the new vehicle, US Accord. So this US Accord includes our first model, IVI in-house software development product. So this IVI system using the Android Automotive OS because we use the Google Map and Google Assistant. So in this means very good IVI product in Accord and Civic. Maybe Civic is Munakata-san and Kate-san, our customer. Thank you very much. So today I have a presentation on AGL SDB reference platform. So this project name is Open Source Accelerated Software Defined Platform Initiative. So this large character was osashimi. Osashimi is so in Japanese food, sushi. Sushi is fish and rice, but without rice means osashimi. So what is automotive Linux is AGL. So our motivation is this point. So we have a lot of open source component in real product, but sometimes very hard work to customize and adapt to ours in real product. So in this case, if some open source community helped us our project, so this is a starting point. 70 or 80% is a very good potential to our open source community. So this is our motivation to these activities. And this is an example of software-defined vehicle, very big diagram. So this is one very big ECU, a high-performance computing in vehicle. One or very big ECU. So in this ECU have many CPU cores and many different operating systems and many different applications. for example, QM level and A serial, A, B, C, D, and different application running to one SOC. So this is one example to software-defined vehicle block diagram. And this is a very quick hardware block down. Please look at this part. So HPC connects to another ECU, for example, AGI ECU. So in this means connect ECU connection using the Ethernet or CAN. But this is many connection to ECU, and we sometimes we use security requirement MACsec and SecOC, and HPC sites MCU and SOC support A series level. So this year AGL focused on SOC sites SDB reference platform. So this one. So this is the osashimi is here. So this software block diagram. So this is a SOC site, and hypervisor is sometimes depend on BSP SOC vendor, because some SOC vendor using the commercial license hypervisor. So in this case, our request BART.io interface support and type 1 hypervisor. So in this means maybe then is one of a good solution to our site. And DOM 0, currently we have plan to using the Zephyr because Zephyr have get certificate ASIL certification in near future, and DOM D is driver domain control to driver, and this part maybe depends on BSP side, and DOM U is we choose some requirement based guest VM, for example, Android Automobile S and AGL, and ELISA is DOM U Zephyr. So in this means this DOM U part without A serial, but some component we use A serial function. So in this means DOM U running on Zephyr. So in this means IC is instrument cluster. Instrument cluster current our maybe our and another OEM needs A serial B or A certification. So in this means instrument cluster A serial function running in Zephyr A serial B certification guest VM. So in this means we are very easy to deploy to without these lines. So this is a very overview AGL different software platform osashimi. And another part, I have some very key component of open source component for SDB. So one is vSAM IP. vSAM IP is a connection to ECU to running the protocol. So this is a very famous protocol in automotive industry, and this is an open source based. So please check this URL. And another is log system because because please look at some pictures upper side. So we have many guest VM running one SOC. So in this means if guest VM is a different log system is so in this case too difficult analyze the debugging in. So same if same log system using the some components. So in this case easy to developing to software developing. So DLP is one of the very good solution to maybe in this timing. Another solution is security topics are verified good. So as you know, Android supports the DM Verity. So in this model is very helpful to our security requirement support, but sometimes the happen to performance issue to bootstrap time. But maybe this is one of a good solution to open source component in this timing. And another is security topics Ethernet security. So MaxSec is one of good solution, and currently Android OS WPS applicant MaxSec is support this component. So this is one of important security topics. And another is kernel LTS topics. As you know, 3 years ago, Linux kernel community decided to LTS term 2 years. So this is a very critical topics to our industry. But as you know, Android generic kernel image. So this is Google provides kernel binary image provide to our customer, some customer. So in this case, Google supports LTS term is 4 years. So in this means Google extends to 2 years. Linux kernel community LTS support is currently 2 years, but Google extended 2 years. So this is a 4 years support Linux kernel source. So this is one of good point to our automotive industry. But GKI is a binary only kernel. So this is a very hard work to adapt to some customized driver. And another is software update because SDB key topics is many times software updates because customer every day report to new function request and some bug analysis, bug report. So we
Every day, but
yeah. So we every day change the software. So in this means software update is a very important point. But current our IVR system and another ECU software program is very big. So in this means we reduce the program size. For example, BS Android using the BS diff is an open source component. So this is one of best solution to use the OTA size. And another is S1 and H topics. So first is we are using the SPDX, right? So Kate and another SPDX member, thank you very much. And because SPDX is very helpful to our software in development because open source compliance is very important to our software development because we have many company different regions. So in this timing that sometimes happens open source compliance issue. But SPDX SPX Lite is easy to understanding. We have a lot of open source, but very clearly to some information. But sometimes we have not not a problem. Maybe Kate-san is I know this word. So please look at this SPDX file. So Linux Foundation provides SPDX tools web page. So this page I use the SPDX JSON file and convert Excel and Excel file or another format. But sometimes happens no assertion package download location. So because this is first build generate SBOM is not correct. So this package download location is a very important information. So we need to some SBOM issues will fix to one build and will fix this correct information.
Yeah, so semantic checking is something that we're improving on the SPX3.
Yeah.
So SPX3 Lite should have the ability to start explicitly saying what can be valid values. If you're caring about that.
Okay, so next is Asian topics. So as you know, this year Linux Foundation Member Summit Kate presentation Zephyr project overview. So I put one page. So
That's fair, I use your slides too.
so currently Zephyr have a plan to get the certification to 26262. So this is a very good news to our in automotive industry. So this is a very good one of our approach to open source project. And another is that Zen is same approach ACL activity, but I don't know. This is new latest information. But so then is some company get ACL self certification. So maybe for example, Renesas-san. So Munaka-san, please quick introduction to Renesas activity.
So I see one page for the Takabe-san. So I just introduce this activity because as you can see, we are now the part of the Zen community to drive safety topics. And you may find we are at the member of the Linux Foundation, AGL, Zen, and the Fire, and we are leading some of the board level activities. But why not ELISA? That's the question. Because I used to be some of you know the CO2 Linux MP. Project that happened in Europe mostly, maybe 5-10 years ago. And I was a part of the review committee of the CO2 Linux. And I decided not to join ELISA when the ELISA happened. Why? That's because for me, at that time, the CO2 Linux MP project tried to bring the kernel versions and narrow down the scope and some limit the functionality. So that's not the beauty of the Linux. Linux is a moving target other than day by day. So, but now I know that the Philip and Kate is trying to sync with the latest Linux and things. It's not easy, but I'm very impressed because a company like Volvo is that's a final users is serious about the making the Linux safety compliant. That's a great news. So I hope that we can be, because I start with the Defiant Zen as a seed of the safetiness, because we try to implement the hypervised environment to compare with the Zen safety and the Defiant as a DOM zero as a safety compliant stuff. Then finally, hopefully Linux should be run as a guest, as a safety compliant guest. So that's my long-term hope, and I try to continue work on this, and because I'm also part of the AGL, and as coming to this, so we try to make some reference implementation to convince the industry that open source can be the safety compliant. So I hope that we can continue work collaborate with you, and at some point, hopefully, I can come back to the ELISA. So this is my message to them. Thank you.
Thank you.
Mhm.
Okay, so this, that's all to our side.
Any thoughts, comments, proposals already by someone? Just be brave, speak up.
Yeah, I have a question, because with all the interest I see on Zephyr from Japan, would you guys need or want or wish for a safety call, maybe not that often that we have it at the moment, but a safety call for Japan in a Japan-friendly time? Because we're meeting on the afternoons, and I know that's hard if you want to connect and ask and contribute.
Yeah, a morning European afternoon Japan time might make sense once a month or something like
Yeah.
that. Would that be helpful? for the working
So
group?
same question to from Linux Foundation, Min.
Yep.
So this is a very difficult answer because なんだろうな in Japan, many Kima have many projects. For example, it's me. I have in real product 3 projects and plus open source community this work. So in this means deep night.
Well,
In Japan, deep night.
no, the question was, yeah, it's a middle of the night call at the moment, so so I'm, as a part of the Zephyr community, just asking, would you wish for us to meet earlier, at least maybe once a month, so maybe in the European morning, so that you guys could join?
That help,
Would that help, or,
when people show up,
yeah,
if we set something up.
or maybe even something asynchronously, that you say, you do your thing, and then you ping us and say, hey, can we have a meeting in the morning? Because there is a lot of stuff going on, and actually, I would love to get more input about your needs on Zephyr.
Nicole, if you don't mind, I will follow up because there's a whole bunch of things that need to be also pulled into safety domain in Zephyr, which we have upstream to Zephyr, but I'm not sure they are part of the safety scope
I don't know.
that are necessary for them, like running in DOM zero. And we do have a whole bunch of, it's like Excel library replacement, which is written in 2005 and everything, which is also open source and partial to install, but it's also not, but it's not part of Zephyr. We are happy to contribute that.
Please do,
Yes,
Yeah, and we happy also to maintain it.
even better.
that's the words I love to hear.
Yeah. But we need this to be, this decision needs to happen. So let's follow up with.
Yes.
Got the sound, got the sound.
That would be great, yeah.
You're right, we have always times of victims.
Yes.
So, but we try to utilize some modern IT technology to automatically translate and make a summary. That's not very useful, and because even not a real-time communication, I can track what you're talking. And yes, I want to jump in if you have good topics.
Yeah.
I will delegate my conversation to ChatGPT.
Yeah.
Yeah, just feel free to ask for a morning call,
Yeah,
it's really would be great, and I'd be happy to. And I think at least, we have now, with Stefan being in Canada, maybe he doesn't want to be as a safety chair in the morning, but
Tobias
Tobias, safety architect, he's in Germany, I'm in Germany. We can make it work.
Yeah, we're seeing more and more interest, so it makes sense.
There is a comment from Ito-san, said I think it's a good idea to have morning meetings in Europe once a month or so. And again, Kabe-san is busy in business hour in Japan. Those late night meetings actually works for Japanese busy guys, including me. Joking. but-
Okay, yeah, I really appreciate your work-life balance, you know, don't want you to call in the night.
Yeah.
The work balance.
If you can't sleep, you're very welcome, but I'm not expecting that.
What I find interesting from all the open source projects which you mentioned, which are with PSAM-IP, with DLT and other parts, and the Eclipse S-Core activities, these are components basically which fit to a certain extent in the Eclipse S-Core stack.
I took a picture of what Kusakawa-san was showing on the slide because I thought like, I recognize these kind of building blocks from the presentation this morning. To some extent, yep.
My question is,
Next page. Next page, so,
And some other one?
Yeah.
next page, yeah, this one.
yeah,
So-
my question is always, we quite frequently see this model of, yeah, we can't trust Linux, so let's have these other things that we know we can trust, that we can, yeah, we know we have some hope of certifying Xen, we have some hope of certifying Zephyr, let's not bother with Linux. I think it would be really useful to say what it is that we actually need Linux to do. What are the things where,
You mean the requirements on Linux?
yeah, but I don't mean requirements at what are the kernel
I
requirements.
know,
I
but
mean
when they're
the,
functional.
yeah, what system use cases do we need Linux for? Because we can't run it on a microcontroller, we can't run it.
This will come from Eclipse SDV, right? I mean, the score.
But again, that's focusing on,
They need to come
That's
from
one
somebody
way.
building a
And
commercial
they need
system.
to come from someone building a system.
what's the system use case, so yeah, so.
Well, the same way when we decomposed on medical, and we went through the STP analysis to figure out what we were actually using Linux for in that system on the article.
And in that case, you probably didn't need Linux because they were very modest. In some cases, you do have some heavy lifting that you really need a Linux scale thing for. But understanding what that is and how you can then make safety arguments around it would really help Linux to move forward as something that you might not be able to trust it to do everything. And you might still need these other components to catch it when it falls. But where you need it to do this heavy lifting, high performance role and identify what that is, and then be able to detect when it's straying off the path. That would help.
And from my point of view, coming back to what you've been saying, Gab, there will most likely be assumptions S-Core is doing towards the operating system. But I guess it's definitely not the 100% view Linux needs to know what is it.
This
So
is too
you've been
often.
saying we need the system view. What is the system?
What is the
view
system
then?
view?
Is that then the I don't know, HPC that entire operating system is running on? Is the system the entire car?
Yeah. That's right.
Yeah.
If the requirements you see are, I need an NASLB operating system, that doesn't tell me anything about what the operating system actually needs to do.
Yeah, but at least, you know, partial assumptions are better than no assumptions.
Absolutely, yeah.
So that would be something, you know, if you had a universal place somewhere where people just place their expectations.
Yes, exactly.
Yeah.
One of the things
Isn't
that.
that the church?
Yeah, that's, we move beyond that.
Didn't work out.
Yeah.
One topic that comes up, has come up a lot in past discussions about Linux is, if you want to use in safety, it needs to be real time. Real time, that's the really important thing.
That's real time.
Yeah, what's real time mean? And we have real time, Linux now, but again, it's what do you need it to do? So
What do you need in terms of
real
the
time could
determinism?
mean predictability rather
Determinism.
than speed. But also Linux does a marvelous job of other things, which is managing shared resources with maximizing the performance out of it. And if that's the task that you need Linux to do in your system, characterizing that task in a way that we can say, okay, yes, we can make promises about that. We can't make promises
And
about everything.
Quite frankly, coming up with things that you're making promises about and making sure that there's an appropriate set of tests available to guarantee and let you test against it. So this is where the kernel CI side is kind of starting to come into play. Is, can we start to express for parts of the options in the kernel, what the test infrastructure is going to be, which is effectively a requirements traceability.
But that's it, it's saying what is it that at a high level I need the system to do, trace that down to specific things, trace that down to, actually I have tests for that. And then you can identify where you're missing the tests.
Right.
And where those tests are failing.
So one thing that I always kind of dislike in this mixed architecture, and I will take some IP as an example. If you usually don't need very complex functions right now, as I know of, for a safety function. So you could do it on a lower level. You don't need a Linux for that, usually for the safety function, but you need to share data with your safety function and your not safety function. And then it starts to get complicated because then you have synchronization issues between those things, and then you have different software stacks between those things. And take some IP implementation that you want to share between 3 different operating systems just to get the speed shared among all those systems. And one of them is relying that this speed is updated on a certain frequency. And already you have a problem that you eventually could minimize a little bit if you could do it only once. Yeah, so as a use case for a Linux, it might not even be that the Linux is the one needed for the safety function itself, but it is needed because it shares information that is not used by the safety function, but is kind of had to be shared with everyone.
Exactly.
And then you would have one pipeline. So that's one of the use cases I see for not going in this split up way, because it's very tough to get development on those kind of systems is very tough to do. You try things out and then you want to put them to, you have to go to the car to actually test them. And that's very expensive. Yeah. So I just use some IP as an example because it's really a pain if you have different controllers doing the same amount of information, but with different timing requirements or sensitivity to timing, let's say like that.
But I'm pretty sure that in the architecture you showed, there was no safety goal allocated to Linux. It was all somewhere else. I didn't understand the part. You showed the picture with
I understood that there was no safety goal to Linux. That was my understanding. My
I wanted to clarify that first.
Yeah.
For specifying.
I think we are talking IVI domain most likely, yeah.
So it's IVI instrument cluster, and you can see that there's the instrument cluster ASIL-B part in the stack, and the
And
rest
that's Zephyr.
in that effort.
So that's no Linux for that. So
it's, yeah.
Which is a fair approach, right?
Yeah.
So you don't need to take, for this use case, you don't need to take the extra effort and say we have a DOM UAGL, which is a safety Linux, or has any ASIL allocated, because the workload which you're trying to cover is better fitted than the other
We
side.
talked about safety and safely. So you can use Linux safely by not giving it any safety responsibility.
Yeah.
That's, you know,
Baseline.
baseline.
Yeah.
But I think we're trying to see what can you trust it? Let's build up from there. You know, and more importantly, where is it actually going to make the purpose of your system, which may actually have a safety role, but not be called a safety function. So if you're, for example, if you're using Linux to process some incoming camera stream and use that to inform decisions that you're making, you could, seen it done, argue it doesn't really have a safety function, but it's still involved in a safety application. I think that's the bit I'm interested in. We do want to use people use Linux all the time in these kinds of complex systems with challenging goals, but then they try to avoid assigning any safety responsibility, and I think that's probably reflects the way people have been thinking about safety rather than what's really.
Safe usage.
I have a question. So with respect to the slide, the other projects we potentially consider. So now, indeed, I mean, all these deck and all I mean, the AGI project, is based on your, right? So however, I was wondering if, I think we also discussed this during the working group about the possibility to include the AutoSD CentOS. That is, AutoSD CentOS is a precursor of the Red Hat Indigo OS. It's a fully fledged binary Linux distribution that can be used and possibly also customized, to test changes or new hardware. So I was wondering if this could be of interest to ELISA or Eclipse SDV. What is, if you've already considered if there is something that we need to do, that
Put someone on the resources to build it into the reference system.
huh?
Put someone on the resources to create an image, an option to put that into the reference system would be the thing.
You mean the reference system of the system working group?
That's that's our sandbox. That's our open sandbox for putting these things out there and trying to get people to work things together. And so
Okay.
just do it out in the open and make it available. If you think that it'll be working, then it'll be in our flows as an option. I don't think you want to get everybody.
I would move it also to another aspect. If we look into the reference system, which we have in ELISA, it has a lot of similarities to the AGL SDB part. And seeing that there is a good momentum, and we had 20 plus participants in the SDB expert group meetings also within AGL, it could also be a good idea to say, like, let's look into the work of AGL and just adopt and adjust the way it's set up. So if we just look into the system part, so yes, I have this line. This one. So if we would take this as a base and go with DOM 0 with Zephyr, and then check, like, do we want to have a DOM B or DOM U with an AutoSD, and maybe remove the Android part, and just like, okay, this is something like, how do we hook in and how can we modify to just get in AutoSD on this? And we don't want to use really the ELISA part, but just say, like, we strip something out, make it smaller, because it should be possible to configure such a system setup to different architectural models. If you cannot do it, then you show that you have something created which is just like the one block. But that's not the intention, right? You want to show that you can change, add domains, remove domains. Eagle.
Maybe it's one counter example, but how would you fit here a scenario where you have well, for lack of a better word, graphic card that is doing something which is safety relevant? I'm not sure you would be able to run that with Zephyr. Yeah.
Maybe you wouldn't run too much graphics cards interaction in Zephyr anyway.
Well, but if you have a self-driving system which is doing that, it runs on the graphic card.
Yeah, you don't just use a graphics card to play games.
There's more and more graphic stuff showing up in Zephyr all the time. That's the interesting thing. So like, but it's like, what level are you guaranteeing is, let's say.
I mean, when you
Just
look at,
substrate.
not here to find to advertise about, like, if you look at Orin or Tor, like this stuff that we does, they are kind of, you have a ARM traditional PC side with the graphic card and some fancy bus in between to fast memory communication.
I do think the Arduino board with the microcontroller and a kind of heavyweight thing as another model, rather than hypervisor is we start with a hypervisor. You can actually say, actually, we've got microcontroller board, microprocessor board with some responsibilities, and we've got Linux running on the heavyweight chip with other responsibilities. It's about the collaboration between those two, and particularly, being able to actually do the work on the microcontroller board as well in the Arduino IDE. I think it would be a really good model to work on.
As a matter of fact, the microcontroller can also run Sapphire.
Yes,
Exactly.
I'm sure I was gonna be asking you that.
Yeah, it does.
I know.
We do have for all the stronger processors, we do both bare metal or Sapphire.
Mhm.
But this stack, SDV architectural overview, this is not Eclipse SDV, right? So this
No,
is
it's AGL.
this is the AGL.
Yeah.
Okay. So Okay, so basically what we're saying, so going back, just to, to close on the, how does the point, so one part would be to include, AutoSD into this stack as a,
Or is to replace some,
Would it-
or maybe to replace some of the octable things.
Or
Yeah.
put options in.
Or
Yeah,
additional
either one or the
but it's
other,
like, I think. Take. Make a concept of what you do on the DOM 0. Would most like keep it like this, take the DOM 0 part, and then. Take the base word I support type 1. So you sit at the base and then consider what you do with this block. And the first step could be to just say, like, okay, I have a DOM D and a DOM U. And one of them is the Northwest. Most likely I would keep the DOM D even there because we have them to build and with the BSP related things, drivers, if you like say. Remove this part, put in an AutoSD. And then eventually on top of the AutoSD, put the Eclipse escort thing in there,
Okay.
for example. This could be a way of showcasing. And what you show then is like, the idea is to add domains and remove domains, and it should be possible to do so. Otherwise, it's,
We haven't done a good reference.
yeah, it's like the references then. Don't get me wrong, just another demo, but we want to have like a reference system where you can build on, where you can base on, and you may have a different way of Android supplier, or you build things a little different, you don't run directly on AGL, so you need to find a way on how to replace blocks. In best case, like you already say, there may be other type 1 hyperconnect. So it says ETC here. And that's the thing which really at the end, this was also the goal of the systems work group to say like, we have here an example, and in best case, we can replace any block, and we may base on Renaissance hardware. So then we go to Arduino hardware, or we have x86 and ARM architectures. So whenever you show that you can swap blocks, you will learn more about the interfaces and the
Right.
dependencies of the system, and that's the key which you need to later on figure out.
Helps us with the analysis eventually too, right? Of our systems, right?
practically speaking, does it make sense? Because, I mean, all of these, if it happens, should happen in the context of the system working group, right?
It should happen, if you take it in ELISA, it should happen in the systems work group, and if you want to bring in AutoSD, it could be a little bit strange if you bring it into the AGL world directly, so you could say the other system part would be AGL SDV expert group, but it's the AGL SDV expert group, and questions will come up when you put in AutoSD from Red Hat in there, which is not octable, nothing to do with AGL. So then it's much better to put it in systems work group.
Yes, and maybe we should first give maybe a seminar or a session explaining how to work without, what is AutoSD, how to work
Yes,
with AutoSD.
yeah.
And then, I mean, I don't think you can just, jump in and do the modification.
I mean, you actually could, but it's much.
No,
better.
yeah, but it's not nice, I mean.
Yeah. To just give also, I mean, you have a motivation, you should show this,
Yeah.
but this could be a way and can show how to build up on a reference architecture. Ben?
So, sorry, I forgot some information, this diagram. So this is this year starting point SDB reference platform because this SDB reference platform without ADAS application because ADAS application needs ACLC or D. So but some feature maybe we will analyze the requirements. So and we will focus to ACLC or D. But this year we have a starting point low level. HLB is a very good starting point because some open source components get HL certification or activity. So this is a very good starting point this year. So maybe this point different S4 project, but very similar to Eclipse S4 project. This AGL side, so we will need more discussion to how to collaborate next step.
Mhm.
A data point, I guess, for you guys for the VM management and monitoring on the left, and then each DOM-U will probably have some level of maybe unprivileged access to interact with Zen. My company is actually looking at extending the Excel tool stack in Zen to have a certifiable library set. So we have a patch set in RFC pending to start that work. Just something to throw out there. I don't think a lot of people talk about, they talk about DOM zeroless, and they talk about that cert code base, but practically to use it, it needs a certifiable Excel tool stack components in DOM 0 and the DOM U's. So
Yeah,
it should, yep.
that already exists.
Oh, it does? That's good to know. So as a subset thing.
That's what we want to contribute to Zephyr. It exists as a library, not as a tool, so you can compile it for RTOS, if you will. And yeah, build on top of it.
Have the patches been sent out already?
Again, it's not patches to Excel, it's
Module?
something completely rewritten. It's not for Linux, it's not for RTOS, it's generic library that you can build for any target.
Okay, interesting.
Okay, we're a little bit over. But I mean, that's normal. I started and I was putting this warning anyway in the beginning.
Yeah.
I would say we make a break here until 5 p.m. for the next 11 minutes, and a half minutes. And then start into the last topic. And we are already a little bit in the topic because we start interacting with communities.
Yeah.
So therefore, we make it a little bit faster, and I'll make break until 5. And I put it in a chat. So,
Thank you very much.
thank you so much.